All right, here we go. Just make sure this is connected. Yep, looks like we're good to go. Okay, minimum operations to make array sum divisible by k. Let's go. Integer numbers, integer k, operation any number of times. Place with nums of I, nums of I minus 1. Make the sum of the array divisible by k. So you can take the sum mod k. I think it's the answer. Let's see. Yeah, that's probably it. I'm just gonna go right for it, right through it. Okay, good. Next. All right, this is debounce, medium. What's the, yeah, okay. FN milliseconds, debounce version of the function. The function's execution is delayed by t milliseconds. Say t is 50, 30, 60, 100. First two would be canceled. That would be executed at 150. Okay, so it says like a floor ceiling function. Okay, let's see. So what you can do probably is divide by the amount 50, take integer division, and then multiply it by, oh wait, what is, execution is delayed by t milliseconds. This execution is canceled if it is called again within that window of time. Should also receive the past parameters. 30, 60, first two would be canceled. It's delayed by 50 milliseconds. Oh, okay, I see. So from third, so the next one is 80, so this one gets canceled. And then this one is 110, but then it gets canceled. And this one's about, oh, okay, I see. Okay. So in this case, if it was 35, this gets at 65, that one gets canceled. 95 does not get canceled, and then 130, so 95 and 135. Okay, I understand. Without using Budash. All right. So what are we looking for? Output T Java. Is it only JavaScript? Oh no. Okay. All right. So the input should be the same, I guess. All right. So if T is 70, so I guess it's just if the next, are these going to be in order? 0,000 calls, that's length. I'm not sure if I can assume these are going to be in order. Oh, I guess they are. Play by 150 and ran at 200. It's canceled by the third. Third call is delayed by 150 and ran at 450. Okay. I guess we just assume the input sequence is exactly what it says. Okay, so T function args. Calls. Oh, this is confusing. Oh, there's inputs. There are inputs. What am I supposed to be doing here? I don't know. I barely use JavaScript. So okay, 91.8% acceptance rate. All right. What does this do? debounds the version of that function. Oh, okay. So it's called with inputs. Oh, I see. So okay, the previous time it was called. Oh man, that's awkward, huh? I guess I would need to keep track of timestamps then, yeah. Oh, oh, this is super awkward. This is definitely not. Oh no. Oh, you think so much harder about this. Uh, so when you call the function, it would get queued. Wait a second. Oh, it's got. Oh, excuse me. It's a delay. Right. So it gets added to a queue. Okay. Hmm. Okay. Probably the easiest way to do it is to have a set, and if the function is still in that set, then oh, that's very awkward. Hmm. You could also have like a validation of some sort where if you call the function, you save the timestamp for when you called the function, then you sleep for a period of time. Do you sleep? These are gonna be called in parallel. This is pretty awkward, huh? What are some of these test cases? Oh man. Oh man, that's pretty awkward. So you would make the function call, and then when the next call comes across, so it would wait, it would sleep. I would want to make this like thread safe, I guess, or probably run on another thread, something like that. I'm not quite sure how I would do that. I'd have to think about that a little bit. It would wait. Then the next, then once it's done waiting, if there's another function that's called, then when it's done waiting, if another function has already been called, this function doesn't execute. It's just canceled. It just exits. Okay. Trying to think there's a way to do this. I mean, I'm pretty sure I could just use a single variable where, I gotta think about it. If I just use a Boolean and I say like function called, right? And then I check if that function with that Boolean is true or not. It'll cancel itself every time, right? Because it'll set it to true and then cancel itself. So there should be like a sequence. So I could use a count as well. So I could do something simple like I'm not sure if there's a way for this function to receive a variable in the scope, but I could do a count. Do let I never use JavaScript, man. So here we're gonna say count plus equals 1, which I don't recall if I could do it that way. Then we're gonna have sleep, which I don't remember had been JavaScript. Sleep for tea time. So if count, so we're gonna say count plus equals 1, and then we're gonna say let we're gonna say const check equals count. And if count is equal to check, then if it's not equal to check, if count is greater than check. So if we've moved on, then we return. Otherwise, we're going to call this function with the arguments, which I think goes something like this. I think this is one way of doing it. And yeah, we sleep for tea time. So let's look at a quick JavaScript sleep for, X milliseconds. Quick. Oh boy, I might get to see my conversations. Okay. Promises. Oh, that's awkward. Okay. Async function example. Can I do this though? Oh, I don't know. I've not used promises in a while. Okay. I mean, I could just set a promise. Okay. How might I be able to? How about this? This might be better. Let me also see something here. Okay. Is my yeah, it's okay. Wait, new promise set timeout. Resolve. Not sure if async. Resolve. Set timeout. I don't really know. T is the but this resolve function. What is resolve? Would like to just execute this code in 1 seconds. Yeah, I just don't remember. I not just not remember. I don't really use JavaScript that much. Fix resolve is a parameter function. You fulfill a promise. Still call back to set timeout. What is the syntax? Creates a function. Right. But what is resolved in this case? Understanding. Solve. So we'll see. Yield the function takes resolve. That's correct. I don't remember. Okay. Mm-hmm. Okay. Okay. So how do I actual function be called? Just pass it directly. Arrow function for inline code. Set timeout. Seconds. Okay. Yeah, I'll use the function, I think. Okay. So we're going to do set timeout. This is going to be 100. Yeah, I kind of messed this up. I should have been able to do this a lot faster. This is going to be arrow notation. Yeah. And we're going to do if count. If count is less than equal to check. Count plus equals 1. Check equals count. Yeah. We're going to say if the count is less than or equal to check, then we call function of ours. Okay, a little confusing, but something like this works reasonably well. All right, how about this? Gosh. Oh yeah, it took forever. It was supposed to be like 3 seconds a question, but that's okay. Hopefully it makes sense. No, it's wrong. In expected output T124. Oh, I put 100. Okay, that was wrong. Got it. It's interesting that I compiled. Oh, there it goes. I think it's right. Let's try it. I'm just gonna go for it. It could be wrong. Oh, got it. Okay, next. All right. Yeah, that was took a while. That took 18 minutes right now. That took so much time. Oh, more JavaScript. Okay. Given 2 promises, return a new promise. Oh, I solved this already. Okay. We're gonna do ones I haven't solved. Okay. All right. Greatest common divisor in a linked list. Okay. Head of a linked list head, and each node contains an integer value. Between every pair of adjacent nodes, insert a new node with a value equal to the greatest common divisor of them. Turn the linked list after insertion. Okay. Interesting. So we're just inserting linked list nodes. All right. Interesting. Does they have a insertion? I have to write the insertion code. Okay. Suppose it's a little awkward, but all right. Let me just see if I have standard GCD. Okay. Yeah, rarely program in JavaScript. Oh, let's just do like 5 and 100, 5 and 10. I don't know why did A be there. Hopefully you can hear me. What is this? Oh, good. Return statement. Usually, I think we just return the head when it's ready. Double check that. Okay, yeah. So we have GCD. All right, that's great. So I don't know. Do a while pointer. Let's do auto. Let's not use auto here. Current is going to be the head. While current is a null pointer. Let's do next. Actually, I like to do for loops instead of while loops if I can. Kind of prefer that. Okay. Next is we're gonna say null pointer. Say if current null pointer and next is null pointer. Then I'm gonna set next equal to or we'll just say target. I'll just name it something slightly different. Current next, say const val GCD, which you could use it's current val and target val. You could use yeah, val constant. Is it integer? Yeah, we're gonna call this a number. I actually don't really like to use num. I like to use something else. We'll just say x. X is fine. Okay, now we're gonna create a list node. List node. We can use. Well, I was gonna say we could use. I think we're gonna use raw pointers. You could use. You could use smart pointers here, but it's a little bit awkward to do it this way. So we're just not gonna use smart pointers for now. Just gonna keep it simple. List node, new node. Excuse me. Yeah, we're gonna put it on the heap. All right. And we're going to say current next equals new node. New node. So there are technically moving memory leaks here, but actually make this even simpler. We'll leave it. We'll leave it. Current next equals new node. Oh, right. And then new node next. It's going to be the target node. And it's a singly linked list, I think, right? Yeah. It's something like this. I think that's it. Memory limits. Whoops. Not quite right, huh? Oh, I know what's wrong. Okay. Oh, yeah, that's not quite right. Current equals new node. There you go. That's the mistake. Runtime error. Okay. Oh, I see. This all goes inside here. I made that mistake. Okay. There we go. I think that's it. I'm just gonna go for it. There are probably some things there that are relevant, but we're gonna skip those for now. How are we doing on time? 25 minutes. Not great, but not terrible. Yeah, I got kind of hung up on one of those questions. Maximum substrings with distinct start. String S consisting of lowercase English letters. Okay, to integer denoting the maximum number of substrings, you can split S into such that each substring starts with a distinct character. No two substrings start with the same character. Okay, well, it's going to be between 1 and 26, because there are only 26 lowercase characters. So I think we just say just all the substrings. So really it's just I think it's a real simple thing here. You just do bool 26 check, or excuse me, check 26. We're gonna fill that with zeros. We're gonna say for const char x and s. We're gonna say check x minus a equals true. Yeah, zero is fine. I mean, false is fine too. And then we're gonna say return std accumulate. I think this works. Let's try this. Basically, everywhere you see a new distinct character, you can have a substring, and there's at most 26. Yeah, that's it. Okay, next. 27 minutes. All right. Score of a string solved. Next. Unlocked. Okay. It's the last one. Yeah. Okay. Solved. Okay. Finishing order. Integer array order of length n and integer array friends. Order contains every integer from 1 to n exactly once, representing the IDs of the participants of a race in their finishing order. Friends contains the IDs of your friends in the race sorted strictly increasing order. Each ID in friends guaranteed to be written in the order array. So 1 to n of IDs of participants, and then some sorted array of IDs of your friends. Okay, got it. Array containing your friends' IDs in their finishing order. Oh, this is the finishing order, and then this is the increasing order, but not necessarily the finishing order. So you want to find each of the friends in the other array where they are. I mean, you could do this in n log n time pretty easily if you could even, probably one easy way to do it is just go 1 to n and then do a binary search to see if it's in the friend IDs, which is reasonably efficient. Another way to do this is to dump all of the friend IDs into a hash set and do the same thing. I think if there's a better way to do this, there might be a faster way to do this, but that's sufficient, so we're just going to do that. We'll do the binary search. So we're going to say for const int ID in order. We're going to say result. There's probably a better way to do this, but this is a solution that is sufficient. And we're gonna just reserve. Actually, I think it's already reserved if I do it this way. I don't think I need to do that. And then we're gonna say const bool check equal, or let's do auto where equals to the lower bound of order or ID and friends in friends.end. And we say if pointer is not equal to friends.end, then we're going to go ahead and result of we'll use another variable too. If I get 0. Result of I is going to be the ID. 3, 1, 2, 5. So 3 is a friend or not. So yeah, if that ID, yeah, I think this is correct. I think it's just that simple. This is a straightforward binary search type of deal. Oh, okay, maybe not. That'd be okay. Huh. What? Something went wrong here. 0, 1, 2, right? What is going on here? I wasn't expecting this to happen the way that it did. How are we doing on time? 32 minutes. We're doing okay here. Oh, 0, 1, 2, 3. Oh, okay. I'm not. Friend should be 3, size 3. The I shouldn't be 4. Why is I showing up as 4? Oh, you know what? I know it's wrong. I first screwed it up. I forgot what lower bound does. I think this is what I'm supposed to throw that in there too. I think that was the issue. Yeah. Sometimes I get a little bit confused. Not confused. I'm not confused, but I just kind of forget what some of the things do. I totally forgot about that. Yeah, it's a greater than or equal, not less than or equal, or even whatever. It's an inequality. It's not an equals. Hey, 0 milliseconds, pretty good. All right. So this one was solved. Solved a bunch of these easy ones. I get kind of bummed out sometimes. I just solve a bunch of easy questions to feel better. Integer array nums. You can add or subtract from any element of nums. Okay, minimum number of operation like all elements divided by 3. Yeah. So this is just going to be the same. We did this before actually. It's just literally accumulate nums.begin, nums.end, 0 mod 3. I think it's this simple. It could be a little more complex than that, but I think it's that simple. I'm gonna go for it. I think this is it. What's wrong? It's not right. Okay. Excuse me. All elements of that's my mistake. Okay, hold on. I think I used transform. CPB ref. CPB add elements after operation. Transform. I don't remember. There's a way to do this, I think. Oh, I gotta take a modulo. It's not meant to add. No, no, no. No, no. Like accumulate, but take each one. Let's say transform reduce. Okay. Yeah, there we go. Okay. Transform reduce. Oops. I was like, I'm pretty sure there's something here. Transform reduce does. How does this work? It's the begin end 0 plus. So we'll keep it simple. Step plus. What's the syntax they used? Okay. I'm not sure about that one. And then mod value. Okay. Check mod 3. Comes the X mod 3. I think that's it. I think that's the whole thing. Wrong answer. No. So take these mod 3, get 1 plus 2, 0 plus 1, 1 plus 2, so I get 4. Oh, I see. It's a little bit, so actually if you get 1, it would be 1, 0 is 0, but 2 is also 1, and you only get 0, 1, and 2 are the options. So it's either a 0 or a 1. So actually it's going to be, if it's not equal to this, I'm going to say steps. How do you, yeah, I think this works. Let's try this. There we go. I'm just going to go for it. A little more complex than the other idea. Yeah, 100% pretty good. How we doing on time? 38 minutes. Okay, we're gonna try to go for 180 minutes. I think 3 hours. Solve this one already. Solved. Okay, partitioning into minimum number of decibinary numbers. Okay. Decimal number is called decibinary if each of its digits is either 0 or 1 without any leading twos. For example, 101 and 1100 are decibinary, while 112 and 3001 are not. Give a string n that represents a positive decimal integer, return the minimum number of positive decibinary numbers needed so that they sum up to n. Oh, that's interesting. So 10, 11, 11, 32. Oh, that's curious, huh? 82734 is 8. This number is 9. I think it's just the maximum digit because the decibinary numbers you're going to add, I think it's just the max. I'm going to try it. It's probably that simple. Okay, reduce standard return, standard max element of, and then we're also going to say, -0, I think. think it's, I'll explain in a minute why I think it's that. If it's just end up, begin, and then end. Something like this, we could try it. Also, I should use a reference here. Yeah, it's probably, okay, this may or may not work. Let me try it. I'm just gonna go for it. Could be wrong. Yep, that's right. There's a reason for that. So the reason is that it has to do with you're adding the decibinary, you're adding like powers of 10, and the decibinary can only add a single power of 10. So, but it can add any like configuration of powers of 10 up from between 0 and 1. So you just have to add enough ones to get whatever the highest digit is, which means you can it's just going to be the largest digit that you need. All right, finding words containing characters. Zero indexed array of strings words and a character X. Zero indexed array of strings words and a character. How are we doing on time? 41 minutes, okay. What's up? Yo, how's it going? Smile Dubber. How you doing? Welcome. Howdy. Howdy. Zero index array of index of strings, words, and character X. An array of indices representing the words that contain the character X. An array of indices representing the words that contain the character X. Okay. I think I have to go letter by letter. Yeah, I have to look at the words to see if the character's there. Okay. It's not too hard, I think. Yeah, so we could do, I think it's pretty straightforward. So eyes, that's the words to the sides. Oops. Command I. I'm gonna say, I could make a subroutine, but also, we're gonna use vector. There's a way to do this that's reasonable. Yeah, we could just do this way. So bool check equals false, or it's or actually const char c, and we'll do words of I. I mean, excuse me. Word current word. Kind of prefer to do it this way, typically. Current word, and then we say check or equals c equals char, which is x. I think this works. And then so if check, then result pushback I. Something like this. I mean, I was gonna suggest that I could make this like a lambda expression, this whole part. But I don't know, that might be overkill for this. I'm just gonna go for it. How do we do time? 44 minutes. It's pretty good. Yeah, not bad. Not bad. That worked. What's up, chat? Oh, what is that chat? Hold on. Oh, what's going on? Did I refresh? Oh, there's a different chat. Oh, oops. Okay. Hi, brother love from India. What's up? Do you say King? Can I do the classic 100 questions in 5 to 6 days? I popped the chat out, but I think I have the wrong one or something. I don't know what happened there. I no. This is all the easy questions, man. I'm just flying through these because these are like the super easy ones. All right. Strictly palindromic. If for every base b between 2 and n minus 2 inclusive, a string representation integer n is base b is palindromic. Integer n return true if n is strictly palindromic, false otherwise. String is palindromic but reads the same forward and backward. Every base b between 2 and n minus 2, inclusive, string representation of the integer n in base b is palindromic. What? Also, I appreciate this is like everybody got this one. I'm like having a hard time even understanding it. If it's strictly palindromic, do I just return false all the time? Reads the same forward and backward. How big is the string? Oh, it's pretty big. Okay. Oh boy. Base 2, palindromic. Base 3, it's not. It's not strictly palindromic, so we just return false. 4, 5. Are there any integers that are strictly palindromic? Only consider base 2, which is not palindromic. I feel like this is just false all the time. Basically, you're gonna take every digit. I think it's every digit. Oh no! Wait. Yeah, is that when you convert the base of something? The way it works is that a number is digits times powers of the base, right? And added together. The sum of the digits times the powers of the base. And so if you change the base, you basically, what do? You basically take that number and break it into a different number, which are going to be a bunch of different powers multiplied by digits again, but just different powers the second time around. It's gotta be palindromic. Oh man, this is, I don't know if anything's ever strictly palindromic. I feel like nothing is. That seems, I bet you could prove that nothing is strictly palindromic in this way with this definition. Every base between 2 and n minus 2. Okay, let's assume, right? Assume every number is gonna be between, yeah, it's gonna be at least 4. Okay. 3 would be 2 and 1, right? Oh yeah, that's why you get a 4, because 2 to 2. Okay, so and these are big numbers, so if we do a brute force search, this will take too long potentially. So we got to be clever about this. That's a really big number. Oh, actually, it's not that big. 100,000. It's not too bad. Base 2, base 3, base 4. It's palindromic. Oh man. That's a tough one, man. I want to just return false. I just want to return false. There's no palindromic numbers like this. No, it's too much. I think you could prove that it's not possible. That like if you let's say it was palindromic in some base, then you could just add 1 and then it wouldn't be palindromic anymore. I think that's correct. Or subtract 1 and then it wouldn't be palindromic. I think you could just return false. I'm just gonna return false. I think so. I'm pretty sure you can like prove it's always not possible. All right, in this case, for the sake of time, I'm just gonna go for it. I didn't prove it, but I think you can prove it. I'm just gonna go for it. It could be wrong. I'm probably wrong somewhere. Oh, it's right. Okay, I told you. This is ridiculous, man. Dude, Leetcode's crazy. Leetcode is crazy, man. It's crazy. I think you can prove that one, but I'm not gonna prove it. It's too much time for that. We're cruising here. We're cruising, man. All right. Convert the temperature. You were given a non-negative floating point number rounded to 2 decimal places Celsius that denotes the temperature in Celsius. You should convert Celsius into Kelvin and Fahrenheit and return it as an array answer. Kelvin, Fahrenheit. Return the array answers within 10 to the negative fifth of the actual answer will be accepted. Kelvin, Fahrenheit. All right. Floating points. I guess we could use. Yeah, we're gonna use doubles. Okay. So what do they want? Temperature in Celsius, Kelvin, and Fahrenheit. And they give you the formula. I mean, is this like super easy though? Isn't this just? Can I do it this way? I think I can do it this way. It's gonna be Celsius. We're gonna rename this to CS. Plus 273.15. And the other one is just 1.80 times CS plus 32. And I mean, am I mistaken here? Did we just go for it? I don't know, man. I'm very confused by this. Okay, yeah, all right, good, 100%. We did it. We did it. Solved this one already. Minimum number of operations to move all balls to each box. Okay, and boxes. What's chat doing here? Doing good. All right. Operations to move all balls to each box. You have n boxes. You're given a binary string boxes of length n, where boxes of I 0 if the ith box is empty, and 1 if it contains one ball. In one operation, you can move one ball from a box to an adjacent box. Box I is adjacent to J if the absolute difference is 1. Note that after doing so, there may be more than one ball in some boxes. Return array answer size n, where answer y is the minimum number of operations needed to move all the balls to the ith box. Each answer is calculated considering the initial state of the boxes. I don't know. I just read. Answer. Okay, so we get boxes 110. First box, move one ball from the second box to the first box in one operation. Second box, you'll have to move one ball from the first box to the second box in one operation. Third box, you will have to move one ball from the first box to the third box in two operations and move one ball from the second box. So they give you 113. What in the world? I'm just reading it too quickly, I think. I'm trying to go quick. I'm trying to go fast, man. Sounding fast. Fast is fast. Binary string boxes of length n, or boxes of I is 0 if the ith box is empty. Okay, and one if it contains one ball. All right, got it. One operation, you can move one ball from a box to an adjacent box. Okay, got it. There may be more than one ball in some boxes. Okay, so it's possible to have more than one. Okay, got it. Answer of I is the minimum number of operations to move all the balls to the. Oh, interesting. Okay, it's calculated the initial state. Okay, so this is actually pretty straightforward. I mean, if it's all ones, then what you're going to do is everything to the left. This is kind of a curious one, but each ball to the left it's a decreasing sequence of like values to how many operations you got to move to your ith position, and then the same thing on the other side. It's like it's an increasing sequence, monotonically increasing sequence. So it's going to be like for each of these numbers, you could pre-process the lengths of the ones and basically create like a prefix array type of deal. I think a prefix array and a suffix array is the way to do it. How big are these? It's only 2,000. So in the interest of time, we're not going to do that. But I think a more optimized solution is I think you use prefix and suffix arrays to do this more efficiently. Basically, you could do like a range query over the operations. I think I want to say you can. I could be wrong about that. I'm not sure. I'm not 100% sure about that. I could be wrong. Don't quote me on that. I think you could do a range, something fancy here where it's more optimized, but we're gonna keep it real simple and just do one by one. Okay. So vector int result is gonna be boxes dot size 0 and result. We're gonna say for I is 0, I is less than boxes dot size. We're going to say result of I equals that number we're going to calculate, which I don't really know what I'm going to call that just yet. We'll just call it count, or sum, or yeah, count is fine. What's a count? Have a subroutine here, which is going to start off at J, and we're going to go to the left and to the right. And this is going to be plus plus J. And this one's going to be minus minus J. This is going to be J is greater than 0. And this is going to be J is less than 0. Oh, wait. No. J is less than boxes dot size. We're going to say the diff, which I could do that too. I guess it's fine. Diff equals, it might be easier to do the diff, do it this way. I know people sometimes give me a hard time about doing double variables like this, but I kind of prefer it. We're gonna do diff. It's gonna be diff times boxes of J equals 1, something like this, and something like this too. It's something along these lines. I don't know. Oh, wrong answer. Wrong. You're so wrong. Okay, I got 101. Okay, why did that happen? Okay. Right. Be 0. So this would add 0. And to the left, diff 0, j is greater than 0, increment diff, decrement j, count plus equals 0 times the first one, second one. So when I is 1, and then this j should be 0. Ah, that's my mistake. Okay. That's subtle. There we go. Okay, I think I'm just gonna go for it. This could be wrong. There's probably some error in here somewhere. I just did this pretty quick. Yeah, that's right. Okay, cool. It's slow. Yeah, it's gonna be slow, but again, interest of time. We're trying to go fast here. There, like I said, there's probably a prefix array solution that I can do. Doing 100 classic 100 questions, 5 to 6 days. That's pretty. You probably could do that in one day, quite frankly. The classics. Sum of all subset x. I'm gonna do it on time. Okay, 1 hour in. I got 2 more hours. Sum of all subset XOR totals. The XOR total of an array is defined as the bitwise XOR of all its elements, or 0 if the array is empty. XOR total of an array is defined as the bitwise XOR of all its elements, or if the array is empty. Okay, think here. Bitwise XOR of all its elements, or 0 if the array is empty. Okay. XOR total of the array 256. Okay, got it. Array nums return the sum of all XOR total of every subset. Oh boy. Subsets of the same element should be counted multiple times. Array A is a subset of array B if A can be obtained from B by deleting some possibly 0 elements of Oh boy. The sum of all the XORs of all the subsets. Ooh. Okay, well, it's only 2 to the 12th. All right. I was gonna say you could do the power sets if you want to do it this way. Every subset. So we just want to loop through every subset and take the sum. 2 to the 12th is relatively small, so this is not such a problem. So looping through the subsets is a peculiar thing. There's one way of doing it that I kind of like. So we're gonna say for each element, it's x and nums. We're gonna have standard vector of vectors. We're gonna say previous set or previous sets. Which is just gonna be empty empty. And then we're gonna say we're gonna say standard vector copy of previous sets. And then we're going to let's do a new new sets or next iteration. I set that equal to previous sets. Copy the previous sets to it. You can actually move. No, it's probably better to just copy it actually. And now we're going to say copy dot pushback x. And also next iteration. Probably a better way to do this is to do like a bulk copying type of thing rather than doing all this pushing back. It may be better to actually we could do this is probably a better way of doing it. Let's reserve. I guess you could do it this way. Previous sets dot size. I'm actually not sure about this. I have to look up whether or not this works the way I think it does. I think it does. I'm not sure. Okay, this might be better, more efficient. All right, now we're gonna work through all the power sets, and we're just gonna create. We're just gonna create the power set. Set. We're gonna do power set equals to move next dimension. There we go. That's kind of what I want to do. And now we can go through all the power sets. So now we can say, I don't know, think I need to do any modulo values here. This is maybe not the best way to do it, but I think it'll work. So if it's 20, yeah, XOR 20, it's going to be, I think it's okay. How many bits are in 20? 16, it's like 8. Yeah, you'd 16 downwards. It's like 31, 32. So the sum over like the power set is yeah, it's gonna be like 30,000 or 40,000 or something is the maximum. Just a rough estimate. It could be slightly off on that estimate, but something like that should be okay. All right. For each const auto v and power set, we're gonna go ahead and result plus equals standard accumulate. I think it's also transform reduce type of deal. Which I kind of had before, which we said powers v dot begin, v dot end, start with 0, then it's going to be standard plus. Oh, actually, no, we're not doing that. We're doing standard XOR, so standard XOR. Standard XOR plus. How we doing? Okay, we're doing on time. I think it's yeah, a minute five, 1 hour and 5 minutes. Oh, bit XOR. Yeah, cool, cool. Can do that. Bit XOR, and then this is gonna be. I think actually it's all I need. Oh no. Yeah. Actually, maybe it's the other way around. Maybe I just do accumulate. Wait, does this work? I don't know. Oh yeah, I have a bad habit of changing variable names in the middle of what I'm doing. Okay, how did we do? There we go. All right, I'm gonna go for it. I could be wrong, but I'm just gonna go for it. There's a chance it's wrong. Oh, that's right. Okay. Yeah, again, a little on the slower side, but again, interest of time. There are more efficient ways to do these things, but these will typically it'll work. It'll at least work. Okay, defanging an IP address. All right, given a valid IPv4 IP address, return a defanged version of that IP address. Defanged IP address replace every period with a. Okay, so it's a little bit more challenging in C++. Yeah. Well, there's actually only 4 sections though with an IP address though. So, okay. I mean, I think there's like it's just a std replace and string. Do you have them? I probably should just use the string replace. Excuse me. By position. Okay. And by iterator, replace the one to choose new string. Okay. With find. Yeah. That's probably the way to do it. Yeah. Okay, I like that. Hmm. What does this do? This replace position length. Places length characters. Could I do this while adding characters? That is 1 character to 3 characters. Each replacement. I'm just looking to see if there's like a more standard way of doing this. Use this overload. You can. Oh. Okay. All right. Let's use that approach. I like that. So while what did they say? They said position equals. I mean, we could use the for loop too. For what is this variable? I think it's size t. Yeah. Okay. Yeah. Size t equals 0. Position. We're gonna say position equals. Position's not equal to std string and position. Might want to do this for clarity's sake. Yeah, Something like this works, I guess. So it's gonna be find, right? It was address. This also should be a const reference. Slightly modify that. Adder dot find dot, I think. Is that all we need? Oh, we do need this one. And then just simple string replace position 1 with this string. Is that it? Is that all? Oh, I do need to copy the string. That's my mistake. Yeah, I do. Whoops. Is that it? That seems. Oh, that's wrong. Yeah, that's wrong. Oh no. Hmm. Oh, that's pretty awkward, huh? I think I need to add 2. I gotta think about this. Yeah, I think I gotta do add 2 maybe. I'm not sure. This might be wrong. TLE. Yeah, it's a little awkward. I'm not quite sure what this is doing under the hood. No, this doesn't really work the way I'd like it to. Okay. Let me see. How would they do? Oh, okay. Exposition. Okay, that's what I should be doing. Ah, that's duh. Of course. Yeah, I don't know why. Okay. It's still not gonna be right though, I think. Mhm. Position. Okay. This one. String find. Yeah, I probably should use the while loop. I don't know. Isn't it not? Yeah, that's confusing. Yeah. Okay. All right. You have to do this before you do the check. That's kind of what I'm getting stuck on. That's pretty awkward. Yeah. That's, I think, the issue here. I was like, I'm pretty sure you could do for loops and while loops are pretty interchangeable. And then I increment past the new characters. Okay. I guess I passed the new characters then. I wasn't too sure about that, whether or not I should pass the new characters or not. Okay. 113. Still TLE. Let's see. Hold on. Oh, there we go. Now it's right. Okay. All right, I'm gonna try to go for this. I'm just gonna go for it. It could be wrong. I'm not sure. I don't actually know. Oh, that's right. Okay, not bad. Not bad. A little awkward. I mean, I'm sure there's a way to like write this code if you wanted to, but this is okay. This is not bad. It's a little odd, to be fair. It's a little odd. I think what happens is that the position that I was at when I looked for the dot, when I delete that and add 3 new characters, yeah, this might not be the most efficient way to do it. Also, just as an aside, but IP addresses are relatively small, so it works okay. The the position that, let's say if you position 2 and you delete the character there and add 3 characters. Even though, yeah, okay, that makes sense. Yeah, so now there's 3 characters there. So normally you would add 1 for that 1 character. To go to the next character, you're gonna add 1, 2, 3. Okay, it's a little odd, but it works. Yeah, it makes sense. Makes sense, but just a bit odd. How are we doing? Now, hour 15. Chat's doing okay. What am I? Okay. Okay. And how is the health of the live stream? Oh, a lot of drop frames. Okay. Okay. Compute alternating sum. Am I having issues with my? Oh, my internet's fine. Given integer array nums, the alternating sum of nums is the value obtained by adding elements at evens. Is it because I'm watching the live stream? Is that maybe why? I didn't even realize I was doing that. I should pop out the chat. Give me 1 second. Pop the chat out. That's really what I should be doing. And then basically close the live stream, I guess. Yeah, that would be kind of a bummer if okay. Forgive me. So the alternating sum is alternating sum of nums is the value obtained by adding elements at even indices and subtracting elements at odd indices. All right. I mean, I could just compute this, right? Is that? I don't know, man. I don't know what was it's the add the even, subtract the odd. Okay. That's one way of doing it. This may or may not be the best, but you can at least do it this way. And then display odd. I think this works. Let's see. Oh no, that doesn't work. I gotta subtract, not add. I'm gonna go for it. What does this say? This says negative values. Okay, that's right. Okay, next. Yeah, the easy ones are pretty easy. How are we doing here? Okay. Okay, sneaky numbers of Digitville. In the town of Digitville, there was a list of numbers called nums containing integers from 0 to n-1. Each number was supposed to appear exactly once in the list. However, 2 mischievous numbers sneaked into an additional time, making the list longer than usual. As the town detective, your task is to find these 2 sneaky numbers, return an array of size 2, containing the 2 numbers in any order so the piece can return to Digitville. Okay. 2 numbers sneaked in an additional time. Okay. So there's like an XOR thing you can do with this, which is kind of nifty. If you exactly 2 repeated elements. All right. So if you take the XOR of the whole thing, right, then you end up with the 2 elements that were XORed out. Those both get removed, which in this case is 4 and 4, and 5 and 5. And then everything else happens to be there once. Then if you XOR that, the ones that occurred once, right? XOR that one more time with the whole list again. XOR that value with the list. Then, well, unfortunately, these ones will end up. There's a better way to do it. I think it's. Trying to think here. If you go by the bits, shucks. There's a more efficient way to do this. So like the really straightforward one is just use like a frequency map. Oh, okay. Exactly 2 repeated elements. There are a few different ways to do this. You might even be able to use cycles or something. You could also sort it to find it quickly. That's another way. And you can use counting sort too. And you don't really need to use counting sort. There's only 100 elements. I think a frequency map is fine. Or just use a frequency map. I think there's a way to do this using bits. It's more efficient, but a lot more clever. But I'm not gonna do that. I'll just say frequency map. Frequency, I think of 100. Right? What did they say? It's between 0. It's gonna be less than or equal to 100. Okay. Yeah, this way. Yeah. I think it was 2 to 100. So yeah, 2 to 100. Could be 1 to 100 though. 0. Okay. Yeah. Okay. Okay. So frequency of high is 2. Oops. Solve dot back. I think it'll be naturally sorted too, by the way. Something like this. I'm dropping frames though, which is not great. So how did I do? I think this is correct. I think I'm just gonna go for it. Yeah, there we go. Okay. I mean, yeah, not much to say there. Number of good pairs. Hour and 24. We still have an hour and a half, only halfway through the time. Given an array of integers nums, return the number of good pairs. A pair ij is called good if nums of I equals nums of j and I is less than j. Oh, this is interesting. So you could use a frequency map for this too. Between 1 and 100. So yeah, it's a little more. It was a slightly more clever way to do this. So same deal as similar to the last one. I'll explain in a minute. From 1 to 100. Yeah. Okay. 101 again. So very similar thing. Ooh. This one hopefully works the way I think it does. Whoops. Yeah, this should be fine. You could do a transform reduce here too, but I'm not going to. Okay, so we're gonna do, it's gonna be frequency of I times frequency of I plus 1 divided by 2. And the reason for that is it's gonna be n choose 2 numbers of ways we could pick the pairs. Oh no, you're kidding. 4 it says. Well, shouldn't this be 1, 1 and 1, 1 and 1, 1 and 1, 3 of these for the ones, and then 2 is 0. If it's a 1, 1, oh, I see. That's gonna give us too many. Okay. So we should get 3 for 1s, we should get 1 for 2, and then 3 should be 1. I think n choose 2 is actually subtract 1. I'm actually not sure if it's a subtract 1 or add 1. It might be a subtract 1. I may have made a mistake. Yeah, I made that mistake there. All right, I'm gonna go for it. I'm just gonna try it. It could be wrong. It could be something subtle that I missed. Nope, that's right. Good. Yeah, I'm sure there's other ways to do that, but that's a pretty straightforward way to do it. All right. How are we doing here? So 20 hour 27. Partition according to given pivot. 0 indexed integer array nums and integer pivot. Rearrange nums so that the following conditions are satisfied. Oh my gosh. Oh boy. We're still around like a 90% acceptance rate question, so like super relatively speaking pretty easy questions. Every element less than pivot appears before every, oh, this is a quick sort pivot. Equal to pivot between relative order of the elements less than pivot. PLI, J. Excuse me, P sub I is the new position of the ith element, and P sub j is the new position of j element if I is less than j, and both elements are smaller or larger than pivot. Then P sub I is less than P sub j. Return nums after the rearrangement. So if we pick a 10 as the pivot, we want to move to 12 over here, basically, and 3 over there. 9, 5, 3. Excuse me, 10, 10, 12, 14. This is the first iteration of the partition for quicksort. And pivot will be element. Oh, nubs. Excuse me. Okay. Okay. The relative order of the elements less than pivot and the elements greater than pivot is maintained. Okay, got it. Interesting. All right. So this is a way to do this. That's good. I think there's like a flag solution, which I don't remember exactly how it goes, but it's something like int I equals 0, j equals 0, k equals the end, nums.end. We're gonna use indices. It's something like this. So I think we always increment I or something. I don't remember now. A is going to be nums I, B is nums J, and C is nums K. It's something like this. You could say you'd say A is if A is less than pivot, else if A is equal to pivot, and then otherwise, this is really A is I'm going to just make it do explicitly. So in these three cases, we what do we do? I think it's like, oh boy, it's been a while. So if A is less than the pivot, we're gonna move it to the front. It's actually J is the thing that we want to look at. And we swap nums of I with nums of J. Something like this. And we increment I. I think J gets incremented at every iteration. And if B is the pivot, then we just increment. We don't move anything, touch anything. And then if we're larger than the pivot, then we want to move to the beginning of I don't think this actually maintains the order. No, it doesn't. No, I don't think we can do the Dutch flag solution. No. Is it? I don't remember. It's been a while. All right, I think I'm gonna look at the Dutch flag solution. It's been a while. In the interest of time. There's a more efficient way to do something. Hey, how's it going? What's up, man? What's up? I just don't remember it. Dutch flag solution. Let's see what comes up here. Okay. Does this maintain relative order of the elements? I think it doesn't. Yeah, so it's low, mid, high. So I got that part right. Well, mid is less than high. You're gonna increment low and mid when you swap. That's what I was gonna do. And the mid, you just leave it, which is what I was gonna do. You just increment the mid one. And then the last one, you're gonna swap and decrement the high. But the problem is that I don't think it maintains the relative order. No, that was the issue. Okay. Stability is required. Counting sort approach. Write the array in order. Okay. Yeah. I think we have to use extra memory. Does this require first? Does doing this with stability imply must use some extra memory? Either perform counting sort or overwrite the array. Yeah, the Dutch national flag solution is pretty good, but it doesn't maintain the stability. It's typically required extra memory. Okay. Overwrite the array. Not practical. Okay. So it is possible to do stable three-way partitioning using rotation-based methods. Okay, that's interesting. Well, okay. What is an example? Algorithm. Complex algorithms. Block swaps. Okay. Interesting. So swapping, which breaks stability, rotate blocks to place elements in the correct region while preserving the relative order. Oh, interesting. Rotate blocks? I'm not sure what that means. I don't know how you do that. And log in. Oh, okay. It's not O then. Okay. GCD based rotation of triple reversal. Interesting. Much slower in practice. Okay. Theoretical interest and rarely used. Okay. Got it. Got it. Got it. All right. We're going to do linear time. We're going to use some extra memory to do this. Yeah. Okay. Fair enough. So the size of the numbers are quite large though. So in that case, we're not going to use counting sort. We're just going to overwrite the array in a very direct way. So we're going to say standard vector int left, mid, right, and we're going to say that reserve nums size. We're going to keep it real simple. We're going to say for constant x nums x is less than pivot, left pushback x, else if x equals pivot, mid pushback x, and finally at the end, x is greater than pivot, right pushback x. And then we're going to say result. Yeah, we're going to do this way. For constant x and left, result pushback x. For constant x and mid, result pushback mid x. I'm sure there's a better way to do this, but this is reasonable. This is reasonable. Also good not to make typos. And then return result. All right, this will keep it stable. Be linear time. A lot of extra memory. Kind of probably on the slower side. Reserve. A few typos. Overall, I think this works out okay though. Yeah, all right. I think we'll just go for it. There could be some mistake that I made that I didn't realize. There's a high chance of that. Nope, got it. 4 milliseconds is still reasonable. So yeah, I mean, weighing things here, but going as quickly as I can. Yeah, okay, so an hour and 40 minutes so far. Okay. Transform array by parity. You're given an integer and array num. This transform nums by performing the following operations in the exact order specified. Replace each even number with 0. Replace each odd numbers with 1. Sort the modified array in non-decreasing order. Return the resulting array after performing these operations. Oh, this is super easy. Okay, so yeah, you ready for this? We're just gonna have we're gonna do it this way. Int frequency 2. Frequency of 0 is 0. Frequency of 1 is 0. And we're gonna say for constant x nums frequency of x mod 2 plus plus. And then we're going to say std vector int result is going to be nums.size of 0. And actually, I could probably even do better than this, but this is probably fine. And then we're just going to fill the ones from nums.begin plus frequency of 0 to nums.end. Something like this. It may be a little bit further, a little more different than this. Oh, okay. So even with a 0, odd with a 1. Um, oh, excuse me. My mistake. Oh, that's not good. Oh no, that's fine. Okay, I think it's correct. I'm gonna go for it. I think this is correct. I could be wrong, but I think this is right. Yeah, there we go. Not bad. That's a pretty efficient way to do that. All right. How are we doing on time? 1:43. Okay. There may have been a better way to do that, but that's fine. Function. Oh, it's JavaScript again. Oh, freaking JavaScript, man. Function f of n, an array of arguments args, and a timeout t in milliseconds. Return a cancel function. Didn't we do this already? We just did this. Delay of cancel time ms. The returned cancel function will be invoked. Okay. Initially, the execution of the function should be delayed by t milliseconds. If before the delay, the function cancel fn is invoked, it should cancel the delayed execution of fn. Okay, otherwise if cancel fn is not invoked, then the specific delay fn should be executed with the provided args as arguments. Oh my god. So we've got an input function, we've got the arguments, t is 20, turns, so exclamation cancel times 50. Cancel fn, cancelable, timeout, cancel fn, cancel timeout. Oh my gosh, man. Ooh. Cancellation was scheduled to occur after a delay of cancel time ms, which happened after the execution at 20 milliseconds. Where's the set of cancel time fs? Ooh. Where's cancel time f? MS? What is it? I always felt like various like JavaScript like concurrency stuff was always very confusing to me. Um, just have all these different callbacks going on. Oh, excuse me. Okay. Um, where does it say the cancel time MS? So confused. What are they asking? So they want. Oh, excuse me. Given a function f of n and an array of arguments args and a timeout t in milliseconds, return a cancel function. Okay. Let's return some kind of a function, cancel function. It's going to be return cancel function. Okay. Which could just be a function. I have to double check the syntax. So after delay of cancel time MS. Okay. The return cancel function cancel fn will be invoked. Okay. Initially, the execution of the function fn should be delayed by t milliseconds. Okay. I guess something like this. I don't know. If before the delay of t milliseconds, the function cancel function is invoked, it should cancel the delayed execution of fn. Hold on. Okay. Before the delay, cancel ffn is invoked. It should cancel the delayed execution of fn. Let's think about this for a minute. So we want to. Oh, you're tired. Ugh. We want to call f of n some amount of time later. Is that right? We're going to call f of n some amount of time later. I'm not entirely sure what to make of this. We'll cancel. It's false. Turn function. This is going to set cancel true. And I don't know, do we set timeout? Um, if canceled. I'm not sure in JavaScript what this is going to look like. I'm not sure this is what they want. Let's say if it's not canceled, we'll come back to the correct syntax of that. If it's not canceled, we call ffn with args. Otherwise, we don't do anything. I'm not entirely sure about this one. Let's just take a quick look. JavaScript not. Excuse me. We do it on time. Yeah, I'm a little bit uncertain about this particular question. Some of these definitely trip me up. You could do not. Okay. It could be the exclamation point. Okay. I don't know if I can do bool in JavaScript. True and false. Okay. So it almost works. Let's see, in this case, 19. Okay, 19, 20. This one. But this one's wrong. What are they expecting? 2, 4, 3, 12, 30 to 100. Return null times 30. T is 30. Cancel time is 100. I mean, this is pretty simple. Doesn't seem to work properly though. Return to null. Could be that this is supposed to be like so. Yeah, okay. I mean, that's a little bit odd, but okay. I'm just gonna go for it. I don't know if this is correct or not. It seems very odd. This could be wrong. High chance it's just wrong. Oh, that's right. Okay. Yeah, I don't know. That sort of thing's a little bit confusing. Like I said, JavaScript can be a bit odd. There's like a few questions there that I have where I'm not really sure why that works or if that should work or not. All right, merge nodes in between zeros. You're given the head of a linked list, which contains a series of integers separated by 0. The beginning and end of the linked list will have node.value 0. Every 2 consecutive zeros. Oh, excuse me. Merge all the nodes lying in between them into a single node whose value is the sum of all the merged nodes. The modified list should not contain 0 in the head of the modified linked list. Example 1031045520. Whoa. Okay. So the 0 to 0 becomes 4. 0 to 0 becomes 11. Oh, okay. Oh, interesting. All right. So basically running sum until you see the next zero. And then I think you just create a new linked list result. Keep it simple. And we're not gonna try to manage the memory here. We're just gonna leave it. Just use raw pointers. Just use raw pointers and keep it simple. Okay. Just let that one. Something would like to listen to some music. Okay. So we'll have this new result. Hold on. Okay. There's at least 3 nodes. Okay, which means there's always going to be. Or no 2 consecutive nodes, the node.value equals 0, beginning and end node.value equals 0. Yeah, okay, got it. Okay, so we'll start off at head here. Oh, no, just a new list node, excuse me. We're going to say result head, and then we're going to say current result. And return the head of that new list. We're done. Okay. We're gonna say while or a for loop. Amount. What are these numbers again? Oh, 1,000 and 2 to the 100,000, which could be 2 to the 100 million, which means it all fits in an int. Okay, that's good. Amount. Okay. So, probably should have a double while loop, double for loop here. I'm going to say list node current is going to be head. Multiplier. Equals current next. List node possible is equal to current possible so to multiplier and possible next. I probably should have come up with a better name than possible, but that's okay. Value is not equal to 0. Okay. So if current value is 0, we'll just jump ahead. Keep it simple here. Okay. Sure. Possible is current. Possible is not a null pointer, and possible is not. It's not 0. I'm going to keep incrementing possible. I think this actually I'm not going to do anything here. Oh, there is something we're going to do here. Amount plus equals possible. Oh, okay. Until we get to the 0, and then we're going to go ahead and results current. So just if it's not the null pointer. This is pretty confusing. This is going to be set to the mount. Then we're going to say result current. Next. Yeah. Oh. Forgive me, I'm starting to fall asleep. There are also some issues with this. There are some issues. Still have a full hour to go through this. Yeah, there are some problems with this one. This is not the cleanest way to do this. The problem I'm going to run into here is that once I get to this 0, I need to potentially create a new head node or just a new node. Yeah. I'll be so tired. I'm very sleepy. Very, very sleepy. Hmm. I think the way to do it is say, if result, yeah, we'll do it this way. So if I want to use this outside of this context here, this outside of the scope. So if possible, it's not equal to null pointer, and possible next, not equal to null pointer. Then we're going to go ahead and say result current next is a new list node. Result current result current next. Yeah, something like this. There's more processing to do. It's something along these lines. Well, it just keeps going. Because I have some. We're going to set current equal to possible here. Yeah, it's a lot of variables. There's a lot going on there. I'm not sure this is correct. I'm getting very tired. Getting real sleepy. Got a little more time here. Oh, wrong answer. Okay. Had 1 instead of 4, but I got the 11. Okay. Yeah, sleep. Result head, result current, current is head. Stop the null pointer. We can set current next. Current value is 0. Then we're gonna set current to current next to continue. That's fair. Then we say okay, possible is for not the null pointer and the value is not equal to 0, we're gonna add this value to the amount. Now we're gonna shift forward to this repeatedly. So for starting off at like 0, 3, 1, we would jump to 3, and then we do 3 and 1. And we get to 0. Excuse me, and stop. Okay. Oh, I'm falling asleep here. This is pretty rough. I don't know if I can get through 3 hours of this. Oh, I know it's wrong. Don't really need that. Actually, I don't know if that's wrong. Okay, that was the issue. I'm gonna go for it. This is probably wrong. It's probably some issue. Oh, that's right. Okay, yeah, not the most efficient. There's definitely a better way to do this. Unfortunately, in the interest of time, try to go fast here. But yeah, if I spend more time thinking about that, also I'm like really tired. I'm starting to fall asleep. Still have like 50 something minutes left. Oh my gosh, there's so much time left. Okay. Count number of maximum bitwise or subsets. Maximum bitwise or subsets. Okay, sure. All right, how many subsets are we dealing with here? 16. 2 to the 16th is a large number. It's like 1,000 times 2 to the 6th. I think it's like 16? 64? 2 to the 6th is 2 to the 3rd squared, which is 8 squared, 64. Yeah, it's like 64,000. Okay, 64,000 sets, I guess. 100,000, between 1 and 100,000. 63,000 sets of size 16, potentially 16. Okay. Find the maximum possible bitwise OR of a subset of nums and return the number of different non-empty subsets of the maximum bitwise OR. Okay. An array A is a subset of an array B if A can be obtained from B by deleting some, possibly 0 zones. Okay, got it. Bitwise OR. Okay. So you probably just go for the quickest solution here, the quickest correct solution here. By quick, I mean quickest to find. Maximum possible bitwise or of a subset is 3, 2 subsets of it. 3, 3, and 3, 1. Okay. This could be optimized slightly because bitwise ORs Actually, this can be, I think, greatly optimized. This solution. Um, it's looking for the maximum bitwise OR is gonna be the OR of the entire set, and then because it's the way that ORs work is they're monotonically increasing as you OR more elements of that sequence. And forgive me, I am falling asleep here. The number of subsets that contain that maximum bitwise OR is interesting. It's not so obvious how that's computed. Um, but there aren't that many ways to get there. You could probably compute that in a more efficient way than just going through all of the subsets. Although in this scenario, you can just go through all the subsets, but I think there's a much more efficient way. You think about it for a minute or two. I think it's gonna be. Oh, I'm so tired. Forgive me. I've been working at like 4 a.m. each day lately. It's been a bit rough. Um, I could find the maximum bitwise or number of different non-empty subsets with the maximum bitwise or. That's a tough one, huh? I mean, I could just compute it directly too. It's probably fine. Yeah, I'm sure there's a more clever way to do it, but just going through all the subsets, I think is fine too. It's definitely it's quick to program. So, oops. All right, let's do that then. Let's keep it simple. Yeah. So let's do int max or standard accumulate of the numbers that begin. End 0 standard or. Okay. Now we can do vectors for the subsets. So power set. Yeah. Again, there's probably better ways to do this, but this is reasonable. Um, um, just see something here. I probably should write. I should probably write better, uh, like power set code. This is like kind of not the most efficient thing to do. Um, yeah, this is like probably not the most efficient code. All right, it's something like this. They'll give me the power set, and then I can say select to 0. Yeah, 4, 5, set result equals standard accumulated. Beat up again, beat at end, 0, yeah, I'm sure there's a more clever way to do this. I don't know. Okay. How do I? Okay. Not maybe not the best. Let's do this. That's a program. Hey man, how are you? How's it going? Justin Rat Singh, welcome. Howdy. It's going well. I'm falling asleep over here, but overall doing okay. What did I do wrong here? Let's see. Powers. Oh, that's what's wrong. That's subtle. I've made that mistake before. You gotta initialize it with an empty set, otherwise this doesn't work. There we go. Okay, let's go for it. I'm just gonna go for it. I don't know. Let's see. Let's see what happens. Maybe it's incorrect. Oh no, it's right. Very slow though. I'm fairly confident there's a much more efficient way to do this, but again, interest of time and trying to solve questions as quickly as I can, using as little time as possible. Time to program, like think it through and program it. Solve this one already, but not necessarily the fastest solution. Reverse string prefix, give it a string s, integer k, reverse the first k characters, return the resulting string. Okay, that's pretty straightforward. So in C++, it's going to be, I mean, you can do this. This is pretty straightforward in C++. I think that's it. Let's try it. Yeah, I think that's it. I'm going to go for it. See how I do. Nice. Not bad. Find most frequent vowel and consonant. You're given a string S consisting of lowercase letters A to C. Task is to find the vowel, one of A, E, I, or U, with the maximum frequency. Find the consonant, all of the letters, with the maximum frequency. Return the sum of the two frequencies. Okay, that's pretty straight. We'll just do frequency map. This is a very straightforward solution of this one. Same deal as last time. So we'll do frequency 26. Step fill. Frequency 26. Save const char C and S. Frequency is C minus A. Increment. Now we're going to say std max. Okay, we're going to return or do const int f1. It's going to be std dereference std max element of the following. It's going to be frequency of, was it A? I'm going to say I'm going to say A, E, I, O, and U, right? A, E, I, O, and U. And then I'm going to do all the other ones. Um, mm, what are those numbers? I mean, there's a better way to do this. Let's do it this way. So A, E, I. I have a better idea. I have a better idea. Okay. Read it this way. I thought I was being so clever with that, but I suppose it was not. So if I equals A plus A, or so A, E, I, O, and U. If it's any of those, then we're going to say F1 equals max F1 frequency of I. All right, so that's the vowels. And this is everything else, consonants. Yeah, I like this approach better. This, I think, is a cleaner way to do it. Time is 2:22 1:30. Okay, pretty good. I'm gonna go for it. This could be wrong. I'm sure there's something subtle that I missed. Nope, got it. Not bad. Yeah, that maybe should have been a little bit faster, but that's okay. Number of unique subjects taught by each teacher. Okay, let's see. Teacher ID, subject ID, department ID. Ready solution to calculate the number of unique subjects each teacher teaches in the university result table in any order. Okay, I rarely use SQL, so it's gonna be a little slower, I think, on this one. Write a solution to calculate the number of unique subjects each teacher teaches in the university. Turn this result table in any order result formats shown in the following example. So input teacher table, output teacher account. Okay. So it's a teacher ID and the subject ID. So teacher 1 teaches 2, and teacher 2 teaches 4. Okay. Yeah, so I could use distinct size as sub. I forget what that's called. Subgroupings. All right, SQL subgroupings. Sample and ID. Other column records. I don't remember how to do this. I'll have to do some looking up here. It's group by basic grouping. So ID, count, sum, table group by ID, aggregate all rows per ID. Having. Okay. So I think what we're looking for is a way to get the top 3 window functions. Yeah, you can create a row number. All right, let's do. I think it's just group ID. Select ID, count. Group ID. Count as subject ID. I think I need to make that distinct. Let's see what happens when I do that. Oh, it's or part of that. What happens if I do part of that? So what did we say it was? It was select is it by ID count as teacher ID. What does it say? Count CNT. What did we say it was grouped by teacher ID? What else? From falling asleep. Falling asleep. Right. Okay. Right. So let's see. Input. What was my output? 3. Okay. So yeah, we need a distinct subject ID. May I distinct groups based on subject. So I can use distinct in there somehow. That would be interesting. Every character is 0. Something about group by, excuse me. Distinct on multiple columns. Ah, okay. Distinct column. Group using custom logic. Okay. Case when the age is less than. Oh, that's interesting. I think I can do. Oh man. Oh, I'm falling asleep. Distinct from table, column, column. Maybe use distinct graded is unique across both fields. Actually, I don't really know quite know how to solve this yet. Table containing only unique rows based on the combination of select distinct. Okay. What does this do? I don't think it's correct, but this is interesting, I think. Teacher ID is 2. Subject ID account. I'm falling asleep. It's not great. Still have half an hour to go here. Oh my gosh. I gotta think about this a little bit. There are a few ways I could do this, I suppose. I could use a subtable or a like a call that can get, I forget what they call that, where I can get the table. It's a little bit easier to process. I can get the table as just distinct pairs as a subquery. No matches. Yeah, excuse me. Falling asleep and thinking about other things. Alright. So oh yeah, I gotta ponder this for a time. I think I'm gonna actually just end up falling asleep if I ponder this too much. So the group by clause is great, but it's not everything. Sorry. I am falling asleep. I'm gonna have to just cut this short, and I think I'm about to pass out. I could use a subquery. Let me see. Subject ID. In the interest of time, I think we'll do it that way. Runtime error. There we go. I'm gonna submit this one and see how it does. Yeah, I don't know if I'm gonna make it through the whole challenge, man. I'm sure there's a better way to do that, but I couldn't think of it without falling asleep. I started falling asleep, man. Oh, it's got 30 minutes. Oh, it's rough. These are starting to get harder too. Array wrapper. Okay. Not much harder, but harder. Yeah, I'm sure there is probably a better solution than the one that I submitted there. Create a class array wrapper that accepts an array of integers in its constructor. Oh, more JavaScript. Oh, okay. The array of integers in its constructor. The class should have 2 features when 2 instances of this class are added together with the plus operator. The resulting value is the sum of all the elements in both arrays. Okay. When the string function is called on the instance, it will return comma separated strings surrounded by brackets, for example, 1, 2, 3. Excuse me. Okay. Array wrappers, huh? String. Okay. All right. Num's length 1,000 by 1,000. I mean, depends on what happens here. In simple terms, you could just kind of do these things direct, like naively, directly. And 1,000 by 1,000 is only a million, and it should work reasonably well. So I can program these things. But yeah, I'm strongly considering cutting this short because I'm very sleepy. Oh boy. Oh boy. Um, Thank you. Oh, I'm falling asleep. I'm struggling to get awake. Value of function string turn number. Okay. Um. Hmm. Oh man. Oh man, I'm just straight up falling asleep. I'm sorry. I probably should stop here. I can't really focus at all. Yeah. All right. I didn't make it 3 hours. I mean, I did okay. Got some problems done. I'm gonna stop it here. Yeah, I keep falling asleep. I'm basically like falling asleep in the middle of it. This question though is probably not too difficult, I think. Um, I'm sure that there are ways to do this that are better. I don't really know this immediately offhand. So I did okay. Got through a few questions. Didn't get the full 3 hours though, because I started to fall asleep. Um, if we get this, not solution, that's not what I wanted. Problem list is something that I wanted. Um, yeah, solve a bunch of questions now. Most of them should be easy. Yeah, I'm falling asleep. Okay, so thank you for watching. I'm gonna stop here because I'm way too tired. And yeah, don't forget to like, subscribe, etc. If you like this kind of content, I'm gonna look to keep making um, YouTube tech, finance, and gaming related content. Yeah, I'm so tired. Okay, well, thank you for watching. Have a good rest of your day. Don't forget to like and subscribe if you like this.